So, hi Varun, my name is Varun. I'm a developer and designer here at Rangle. And I wanted to talk about building snappy apps for Cordova, or what's basically high-performing apps for Cordova. Before I go into the performance aspect, I just wanted to go over some of the basic ideas of how a browser actually works, and specifically the rendering engine side. So the first step is usually, the browser loads up the markup and actually turns it into the DOM tree. Once it has the DOM tree, it converts it into the render tree, which is essentially a visual representation of the DOM, where each element is in the correct order as it will have to be when it's being painted. The third step is then that it actually goes ahead and calculates the position and sizing of each layer. This is also known as the layout or the reflow. And then the final step is to actually draw the different layers on the screen. This is known as painting. And when it comes to performance, it's usually the last two steps that are really important, because those are the ones that take the longest, and those are the ones that are most likely impacting your app. And when you think about performance, one aspect that seems to be really important, or coming more into fashion for web development, is the 60 frames per second mark. Humans usually need about 24 frames per second to get a sense of illusion of motion, but for that motion to be really smooth, you need at least 60 frames per second. And game developers have been using this target for the longest time. It's only now creeping into the world of web design and app design. So if you're trying to make an app that runs at 60 frames per second, it means you only have 16 milliseconds per frame. And in that 16 milliseconds, the browser has to evaluate some JavaScript, recalculate styles for any of the elements that were updated, recalculate the layout if you're modifying the styles in JavaScript, and then draw certain parts of the page that were marked as dirty. And then finally, they actually send these layers to the GPU, and then that's where it's put on the screen. I really like this quote by Paul Lewis, because it actually tells you the core idea here. There isn't really a silver bullet when it comes to performance for web apps. What you really need to do is understand how the browser works, what it's doing, and try to optimize for that. So I'm going to go through the various things that you can try and optimize. And the first thing is reflows. So this is when you affect the document content or its structure or the position of an element. Whenever you do that, it's going to cause a relayout or a reflow. And reflows are usually quite expensive. They're so expensive that you should generally try and avoid them. And these are all the different CSS properties that will actually cause a layout. So if you're trying to animate any of these properties, sorry, I'll just leave that on a little longer. So if you're trying to animate any of these properties, it's going to generally take a long time and cause lag in your app, so you should try to avoid them. The second aspect is repainting. This is when the browser takes a DOM element and converts it into a bunch of pixels and then draws them out on the screen. And here are all the properties that will actually affect repainting. So when you try to animate one of these paint properties, what happens is all the elements that were affected by it get repainted. The layer that they belong to. So even though a DOM element, you might be only touching a particular DOM element, it belongs to, there's multiple layers that the browser makes, and the layer that it belongs to has to be repainted too, because this element is part of that layer. And the way GPU works is it actually draws these layers and not individual DOM elements. And this works fine on desktop. If you have big powerful graphics cards, you can draw a lot of layers. But on mobile, this tends to become a problem. There's a limited bandwidth between the CPU and the GPU. And if you have a bunch of layers, then it's going to clog up that bandwidth, and it actually ends up causing a big lag in the frame rate. Therefore, if you're trying to animate these paint properties, I would generally recommend not to do that on mobile. On desktop, you'll still be able to get away with this. So at this point, you're probably wondering, can you actually animate anything? And the answer is yes. If you're trying to animate position, scale, rotation, skew, matrix, or even opacity, you can use the transform properties, and there's a bunch of transform properties that just all of these properties you can animate without any kind of performance impact. They're not going to trigger a layout, or they're not going to trigger a paint. So it's a bit of a no-brainer that you try and end up animating with this. Normally, you might have in the past done, moved an element around by changing top or left. So instead of doing that, you can use the transform translate property. Same thing for animating width or height. Instead of doing that, you use the scale X and scale Y property. And then of course you can do things like rotation and skew, which weren't possible with all of those older CSS properties. Another thing that you can leverage is GPU compositing. GPU compositing is this process where you take individual textures and upload them to the GPU, and then they're drawn there either one by one or even in parallel. You might have heard of this hack for setting translate Z 0 or translate 3D 0, or even the new will change property. And all of these hacks essentially end up leveraging the GPU compositing. And this is known as the null transform hack. So what happens is when you set translate Z 0 on an element, what it does is it creates a new layer with only that element on that layer and a backing surface. That means that DOM element is now mapped onto a texture which is being pushed to the GPU. And then during the time it's being animated, you're not updating that texture, so the CPU doesn't have to rebuild that texture, and it only needs to be built out once, which means when you're animating it, it doesn't get repainted. So what can this do for you? This is an example from the Atom IDE by GitHub. On the left is their initial prototype, where they were having issues with really glitchy scrolling. And what was happening was every time the user scrolled, you can see that the entire screen pretty much is being repainted. And then to fix this issue, what they ended up doing was set that entire div with the code content to be translate 3D 0. And as the user scrolls up and down, they just move it up and down using the transform properties, and then that reduces the repaint area just to the scroll bar on the sides, so giving you a lot better performance. But of course, with all good things, it has to be used reasonably. You can't do too many layers. It can't be turning every single element on your page into a layer, because there is limited bandwidth between the CPU and the GPU, and all of these textures are uploaded into the VRAM for the graphics card. So there's only a limited amount of space that you can access. So there's a limit to what you can do. And of course, mobile phones have a really small amount of VRAM, so you can't do too many textures. So you have to pick and choose, which texture does it make sense to be putting onto a separate layer, and when it doesn't make sense to put it onto a separate layer. And I'll get into that in a bit. This was an example from Apple's homepage a while back. They made a carousel animation where a bunch of things were flying in and out, and they decided to put everything on a separate layer. And in the end, it actually caused some jankiness. And someone went through and tried to debug it and just got rid of a few of these layers, and it just ended up giving a lot better performance. So the most important takeaway that I can give you today is that instead of focusing on all these rules, even the ones that I just stated, because they're likely to change quite quickly, you should really be focusing on tooling and learn how to profile your apps properly and figure out what's causing these performance lags in your app. And the way you can do that is by profiling animations and scrolling in your app. And to do that with Chrome, what you do is you open your app in a new tab, ideally in incognito mode, because depending on what extensions you have, it might cause some issues. Open up developer tools, and then go to the timeline tab. And you should see something like that. And then if you hit the record button on the left-hand corner, it'll start collecting all the events as you're using the app. And once you stop recording, you'll end up seeing something like that. So what does that mean? All of these bars that you see are one frame at a time during the time that you were recording. And if you go look closer into that bar, what you see is usually a stack consisting of how much time it took for loading, for scripting, for rendering, and for painting. And then you would also see two horizontal bars going across your timeline, one that says 60 FPS and one that says 30 FPS. So the target is that the total height of the bar for each frame should be less than 60 frames per second. And that's essentially the 16 millisecond time limit that I spoke about earlier. So that means if you're trying to do any kind of loading or scripting or rendering or painting for that frame, it should all add up to less than 16 milliseconds. Another really good feature on the timeline is filter. As you're recording, you'll notice that you're recording hundreds, if not thousands of frames, and a lot of them might be kind of just empty frames when nothing's happening and you don't really care about it and you just want to focus on a certain subset where you're actually repainting or doing a relayout. So you can just hit the filter button and it will just get rid of all of those frames for you so that you can focus on the few that you want to really care about or the few that you want to inspect. So what can you do with this? One of the issues that comes up a lot is long paint times. So if you see one of the frames is taking a long time, you can sort of zoom into that area and check out what's happening. In this case, the one big green bar that you see in the middle, if you highlight a little bit of area around it, you can see all these different layers. Well, these are basically events that are happening. And then if you zoom in, click onto the parent event, you see there's a big green bar. And then if you open it up, you see there's another slightly smaller bar, but still fairly big, and then a bunch of small bars. So what's happening here is that you have an element on your page that's taking a long time to load. And if you select that paint event, it'll actually tell you what element is taking that amount of time to repaint. And in this case, it's just a div with a huge background image that's taking 312 milliseconds to paint. And remember, you only have 16 milliseconds. So in that case, the frame's going to drop. You'll actually see really janky scrolling. Another example is layout thrashing. So this happens when you're trying to do a lot of DOM reads and writes through JavaScript, because each time you do that, it's causing a reflow. So in this case, again, you notice that there's a really big peak in your timeline. So you zoom into that, and you notice that it's a function call. Inside that function call, when you expand that function call, you notice there's a bunch of relayouts happening. They're all happening around the same time, but they slowly add up, and it takes a long time. And if you go into the details section, you realize that it's taking 139 milliseconds, which is, again, dramatically over the 16 millisecond limit. So you can use this to zoom into that function call, figure out what's happening, and try to optimize your code. Another great tool that Chrome provides is paint rectangles. So this is, again, an example of the Apple website. What paint rectangles do is they show you the area of the screen that's being redrawn. So as the user is interacting with the app, you'll see flashes of green, or you'll see green boxes floating around every time something new is being drawn on the screen. The way you bring this up is by opening up the Chrome DevTools, hitting Escape, which will bring up this submenu, and then going to the Rendering tab, and then just toggling whatever you want to see. This becomes really useful when you're actually trying to figure out whether it makes sense to put an element onto its own layer or not. If you're noticing that the entire screen is being redrawn because you changed a property for an element, it might be a good idea to move it onto its own layer. That way you can reduce the paint area dramatically. That's what they do in this case by putting those arrows on the side into a separate layer so that every time you show or hide them, only they're redrawn and not the rest of the page. And lastly, I wanted to talk about imperative versus declarative animation. Generally, it's preferred to do declarative animation because the browser really knows how to optimize it, and it can actually do that ahead of time and give you much better performance. But unfortunately, you can't really do that every single time because you might have dynamic styles that need to be generated, and you have to set them through JavaScript. So what you do in that case is avoid layout thrashing. So instead of doing a lot of DOM reads and doing a lot of DOM writes separately, you try to group them together. So don't change styles individually, do them all together. It's preferred to use to set a class name instead of setting individual styles. But if you have to do dynamic styling, then you have to kind of generate a style string. So again, instead of setting the CSS property using jQuery or setting individual CSS attributes, what you can do is set a new CSS text string. And then you can take this to the next level by using requestAnimationFrame. requestAnimationFrame, essentially what it does is it sets up a function that will be executed at the next frame, which is essentially similar to using set timeout with a 0-second delay. But what happens is the browser can really optimize it. It groups all of these functions together and executes them together. So what this allows you to do is write your code in a better manner. So you can have DOM reads and writes for a particular element that you're controlling in the same place, and then still execute all of those DOM reads and writes together when the next frame is executed. That's about all I had to talk, and I'm going to hand over to you.
So I want to now follow this up. I'll try to follow up Varun's excellent talk with a talk that actually might seem in context a little bit naive, because it's sort of an actual project that we worked on and some of the lessons learned in it, now which we did a few months ago, and so we didn't actually know everything that we know now. That project might have gone a little different. We might have perhaps applied some of those other things there, but let me just talk about how it was. So we had a project where we wanted to implement inference call on a phone while building a Cordova app. And we wanted in particular to have this work on older phones. So the challenge was inference call, older phones, like, I'm not old, but like Galaxy Nexus, Galaxy, sort of like S3 kind of things. In particular, Android was, we found soon that really Android was giving us problems as opposed to iPhone, as opposed to even older iPhones. And we wanted to make it fast. Now, first thing, that this actually came out slowly and didn't become immediately obvious, and there was a little bit of, I wish we got this clarified, so we had this a little bit clearer in our minds before, from the beginning. There are really different kinds of slow. When people say that app is slow, what they mean can actually vary quite a bit. And so what we eventually realized is that there are sort of three different things that were potentially slow. One is, in an inference call, when you scroll and you get to a bottom and you run out of data, then you hit a wall and you have to wait a little bit. And so that was one sense in which the app was slow. The second one was the occasional non-responsiveness, where you actually try to flicker it to make it go up and it doesn't quite respond, right? And then the third one was so just kind of overall sluggish scrolling, where you make it move and it moves, but it just doesn't really move with the speed with which you want it to move. Now, the interesting thing there is about this distinction is that it was sort of important to actually clarify this eventually, because when people are saying that, well, it's still slow, it's not, no, it's actually not so slow, it became potentially a little confusing. But also that some of those, I mean, fixing some of those actually ended up exacerbating the other ones, right? So I'll talk about this in a second. So the first thing that we started looking at was the actual, this waiting at the bottom. So again, so you scroll down to the very bottom, to the end of your available data, and then at this point your application goes to fetch more data, and you kind of end up waiting for until the data comes back from the server. So that was an easy fix. Really, what we ended up just doing there is adding an asynchronous fetch queue. Right? So instead of waiting to ask the server for new data when we actually need it, we would maintain a queue of items that has come from the server that are ready to go. We would sort of found kind of what seemed like a good number, let's say maybe it was something in the range of 50 to 100 items, and so that when we go ahead and we scroll to the bottom and we want more items, we could go and reach in and immediately get them. This was done using an asynchronous interface, so that in the worst case, if we actually turns out the user had been scrolling so fast we've run out, and there is sort of a graceful handling of this. But in most cases, if the user actually makes a pause occasionally at least, then at that time the asynchronous queue catches up and actually gets more data from the server. And so normally, unless the user really tries to race, they can't, like this sort of, when there's no, they never actually see the end of it. This sort of this scrolling, this kind of scrolling indicator at the end. Well, that seemed, that was working. So that we implemented that. It turned out that helped quite a bit, but it didn't really quite solve the problem, because what turned out is that, well, when even if we eliminated the server delay completely, just simply the act of adding those new items ended up introducing a performance hit. Right? So you would still get to the bottom and have to wait until the new items appear. And what we realized is that a lot of this was actually had to do with the cost of rendering those new items. And so we've looked at a couple of other alternatives. So, and also just the cost, it seemed to be some of the cost associated with just generally ng repeat, which is how was our first most naive implementation of this. Now we looked at that point at a directive that Ionic provides called collection repeat. And what collection repeat does is that it allows you to, it really optimizes displays consisting of a large number of identical of items of identical size. So you could throw some, say, like 1,000 items at it, and you would end up scrolling fairly fast through them. And as we later discovered that the approach we ended up taking was fairly similar to what they did, but the collection repeat, unfortunately, itself as is didn't work for us, because it had an important limitation that your items actually had to be the same size, the same height. And we were dealing with items that varied in height, where we wouldn't know how tall they are until they actually come from the server, so that approach ended up not really working for us. So what we ended up instead is starting to look at removing Angular. Now, when I say removing Angular, by the way, I don't mean just sort of skipping on Angular altogether, but using Angular for all components of the application except for the actual content that is scrolled. So, so it ended up being kind of a little bit of do-it-yourself without Angular, and how did that go? So we ended up, because we realized that a big chunk really was this rendering. Now, when I say rendering, it's just simply taking data items and even generating HTML for them. So what we ended up doing is we added a second asynchronous queue, which would use handlebar to convert, to generate those HTML for each of the items. And we could do that asynchronously, so that it doesn't actually cause any sort of blockage, because each one goes and sort of gets rendered in its own, as its own event. Now, we probably at this point could have actually offloaded this to the server, but within the context of this project, that just wasn't feasible. So we decided to do it in the client, but kind of also took an approach that would allow us later to move, or would allow the client to later move rendering of the HTML to the server if they wanted to. So in that sense, handlebar is what actually ended up being kind of a good option compared to, say, trying to figure out how to use Angular templates for that. So then, now what the nice thing about this of taking Angular out of the loop is that it allowed us to then, now that we basically get those rendered HTML, is to look a lot more precisely at all the different methods of actually adding it to the DOM. So what we've discovered is that there was sort of a magic number, where if you actually add a whole bunch of items at once, then your performance suffers. If you add each item individually, your performance suffers. And instead, what seemed to work best is to actually add them in batches without making the batches too large. So I think we ended up in the end working with batches of about 10 items. So we basically would render the items individually, convert each item to HTML individually. We would maintain an asynchronous queue of rendered items, so that now when you scroll to the bottom, at this point we're not going into our server data queue and saying, do we have data for the next item? We actually go into our queue of pre-rendered HTML chunks and saying, let's put 10 of those into a batch and let's add this to our DOM. And then finally, we also, at this point, discovered that using requestAnimationFrame, as Varun mentioned, also helped a bit. And so we could also play with exact methods of like kind of getting into the good old question about whether you're better off inserting facelifts by setting inner HTML or doing other methods. Now, we implemented most of this. I mean, it wasn't entirely outside Angular. We did this. We implemented most of this as a skinny directive, but it was really a skinny directive in the sense that it was a directive that basically would get its element, and then would pass that element to a service, which would at that point switch to just raw DOM, not even JQLite, but just raw DOM, and will start adding elements using just at the end of the day by setting inner HTML on that. This approach did actually help performance quite a bit. It had a bit of a downside. The downside is that, well, it's still a lot of work. I mean, when I say a lot of work, I don't mean performance-wise, but it's just maintaining those components without Angular. I mean, you sort of realize why do you usually use Angular on the rest of your projects, right? Why we don't actually go and code everything like down to the metal at the level of DOM. But it ended up being actually a good compromise, I think, because of that whole app, still, probably good 95% was done by Angular and was done very easily, and then this one piece where performance really was suffering most, we did in raw DOM and got the performance benefits. So I think it was a decent compromise. Now, as we looked into this, we've run into a sort of an odd dilemma, which is that as you can scroll faster, you can scroll more, you can get more content. As you can get more content, so we got to a point where actually you basically don't see really you don't hit the bottom of yours. Like you could really sort of, in a way, doing infinite scroll where you scroll and scroll and scroll, and it kind of just looks as all the items just have always been there. Unless your server is really slow, where you scroll so fast that we just can't, where our request to the server just can't keep up with your scrolling. In which case, of course, there's very little to be done other than getting a faster server. Now, but as you accumulate more content, scrolling gets slower. Now, it's a very different kind of slow. This is not the slow that you get when you hit the bottom. This is just you start getting sort of non-responsiveness, and it sort of became fairly clear that a lot of it had to do with just, if I may speak loosely, the weight of your DOM, which seemed to be mostly attributable to actual redrawing, right? So we ended up, to solve this problem, we stole an idea from LinkedIn. This is an approach that, we've sort of thought about it first ourselves, but then once we started looking, we found that LinkedIn have documented that solution in detail, and so we basically, to be honest, just did pretty much what they recommended doing, which is removing hidden batches. So what this means is that, so now you can actually realistically scroll to a point where you've got 1,000 items loaded on your phone, right? And those 1,000 items are 1,000 fairly, good chunks of subtrees of DOM, because each item is actually fairly complicated. So now you've got 1,000 of them, you kind of expect performance problems. So what we did is, and again, this is the idea very much borrowed from LinkedIn, is we would watch where all of the items are relative to the viewport, and as they scroll past a certain distance, we will give them a little bit of a grace period, because maybe you're just going to change your mind and suddenly start scrolling backwards. But once they are, say, 500 pixels past, then we go ahead and we measure the size of the div as it is at this point, and we replace it with an empty div of the same size. Right? Now, the size there is important, because if you don't do that, then your scrolling gets messed up, and sort of content just starts moving around. And as we, but if you replace them with fixed size divs, then the user actually doesn't know any better that they're gone. Right? You can't really tell, unless again you happen to make scrolling so fast. So in a way, where at this point on the older devices, this illusion was sort of ended up being very, full in the sense that you will really never see those gone divs. Because even with our best efforts, there were still limitations to scrolling. Now, on the newer devices, of course, the downside of this is if you scroll super fast, then you can sort of scroll through those 500 pixels so fast that suddenly your application is like, wait, where are those items? I need to go and reinsert them. So, of course, what you need to do there is kind of ideally adjust based on your device and the sort of scrolling speed, where how much do you actually how much of a window do you leave. And then the flip side of it also is that we at that point ended up switching from this idea of actually of rendering items when they adding rendered items when you hit the bottom, to instead whenever we get the item from the server, we would actually at that point create a div, an empty div, and then those empty divs would get rendered when they get close enough. So the solution was basically symmetric from the top and from the bottom. So we didn't really need this concept of getting to the bottom, because within this approach you really can't quite get to the bottom. As you get to the, because you always have a bunch of divs in the bottom that are small now because they're empty, but as you start getting close to them, they expand because the content actually gets inserted into them. So then a funny thing happened. We solved it, we were actually fairly happy, and then at some point later we realized that the slowness was back. And it was an interesting sort of part about process in the sense that because there was a sort of a big focus on scrolling and also on performance, and then at some point that was resolved, and then there was a focus on bugs, and then at some point someone was like, it's slow again. When did that happen? So we actually had to do a little bit of, if I remember correctly, I think we actually ended up using git bisect to go and figure out back, like, when did it happen, when did it go back? And now it turned out that what happened is that one of the things that is at some point one of the things that we did fairly early on is just for good measure, we got rid of iron scroll, just to see that it wasn't interfering with anything. Then we switched to overflow scrolling, we did a whole bunch of other optimizations that I talked about, and then in the end at some point we discovered that there was a couple of features that the pull to refresh that was available with iron scroll that we wanted it, and so iron scroll got put back. And at that point, there was a fairly big performance degradation that kind of didn't really get noticed right at that moment, and we only got reported a little later. So that's kind of an interesting question about keeping track of those things. Now, why? So at this point, we actually switched back to overflow scrolling, and because we. Now, why iron scroll was letting us down, we actually never quite figured out because the project ended. But in theory, based on what Varun is saying, that you would actually expect that overflow scrolling would be a worse solution, and iron scroll ought to be able to do better than that using translation and by putting the item in a separate layer. But that's a mystery that we hope we can resolve one day.
Or reducing function.
Oh yeah, no, so then of course the other thing is that within this project, a lot of the focus really was on optimization at the JavaScript level, right? But I think that as you might realize having listened to Varun, a lot of our focus maybe should have also been on CSS. In fact, one of the things that struck us later is that we probably could have gotten a fairly big performance boost by just getting rid of all the rounding of the corners, because that appears to be a really, really expensive component. And there was actually quite a bit of rounding in that interface. I mean, now in general, this was a fairly rich, so the DOM structure was actually fairly complicated, the styling was fairly aggressive. We wanted ideally to actually not have to change it and to just make it performant as it was, but definitely the next step would have been to look very aggressively at how can we actually just sort of get rid of the more expensive forms of styling. Thank you.